Is it really? Why? Okay. There's somebody else talking to me. So let me share this real quick. So one question I got was number 63 and 66 here. So this was obviously about exponential, some kind of growth, exponential growth. So in the year 1985, the house was valued at that. The value appreciated to that. What was the annual growth rate between that and that? So that part shouldn't be too bad, right? Maybe. So they give you two, so there was a set of problems earlier that you had to do by hand. Here we go. So if you were able to do these problems, right, because later they give you one that you can do in the calculator. And we looked at how to do that in the calculator with the lists. We did that yesterday. So if you weren't here, then the video is up there because I'm way too nice. So look at this problem, 63. Do they give you 2 points in 63? Yeah, and if you want to be nice to yourself, so can somebody tell me 1 point that they give you in number 63? 1 point.
1985 and 110,000.
Yeah, you could use 1985, comma 110,000, but do you understand that would suck as an input? I don't want to put 1,985 as an input. So since this is all about starting at 85 and going forward, let me go ahead and call 1985 what instead?
0.
0, because then my variable can be number of years since 1985. So 1 point would be 0, 110,000. Is everybody with me so far? So by the year 2005, it's gone to 145,000. So what's that point going to be?
$20 and 145,000.
20. It's 20 years later. So it's 20, comma 145,000. And then you can figure out the equation for the exponential growth. So are you guys okay with that so far? Okay. Are you really okay with that? Because it's a little bit different from the one from earlier. So they don't really give you enough information here, but they do. One thing you should really enjoy with this level class is that they still give you examples. So this is what we're going to use here. Should be. I'm trying to see if that's, because these problems are all about that kind of thing. Yes. Yes. Because then in this equation, where'd it go? There it is. R is the growth rate per whatever time. So now I want the growth rate per year. All right, so let me kind of help you guys out a little bit. So we got, I need some room. That's a little bit of room. Okay. I also need to change screens, so too bad for you. Hold on. All right. Annotates. So I've got, so here's my problem, 63. Got my 2 points, 0, 110,000. Holy shit. There you go, buddy. This pen, I swear to God. And then 2005, which we figured out was 20 years after 85, 145,000. Right? And I've got my formula They use a little a here for some reason. But I know what the little a is going to be, maybe, right? Because when I put a 0 in, all right, let me stop for a minute. Let me stop. So everybody with me so far? So this is the model. This is the model for exponential growth. If I can figure out what R and A are, then I've got the equation, and then I can answer any other question they want, like 2010. So if I plug in what I get from this point, if I plug it in, hopefully you guys see when I put a 0 in and a 110,000, little a is going to be 110,000, which makes sense. That's little a is supposed to be like principal. It's supposed to be the beginning amount. So then I know this much now. Why am I doing all this float? And then you use this point, you plug that in. Where's that going to go? 20. What's your input?
T.
T is your input. You're going to put 20 there. And then you're supposed to get a 145,000 out here. Right? So we'll have 145,000 is an output if your input, oh, get out of there, equal sign, is 20. So now you can solve for R. Or can you? Let's see if we can. Maybe I'll bring this up on the board so I have actual room. Is everybody cool with the fact that these two things are points? These two sentences are actually mathematical points of data. Okay. And then I can use those in the general form to figure out what are called parameters. The little a and the t, not the t, Jeff, t is a variable. The little a and the r are parameters. They are a little more special than the variable. It's sort of like m and b in an equation of a line. M and b are the parameters of that equation. Right? X is the variable. Who gives a shit? That we're used to. The m and the b are special in a way. They are constants, but they are determined by situations. Right? What's my slope of the line? So okay. So how do I solve? So I'm gonna stop sharing. Somebody's chatting something at me. Let's see. I'm not sure what that means. Let me go to the board real quick. I'm gonna clear this stuff. All right. I don't know if you guys have got everything you want from this business. It's not much up there. It's gone. It's gonna go away. Bye. All right. Stop sharing. Okay. So. Just in case you're here, I decided to drop all of my tea that I had earlier, all right here, about 4 minutes per class. So that was exciting. So I've got paper down. So if you hear me scrunching, that's what's happening. So now we've got, oh shit, I should have written this down. So what was it? 145,000. Oh, you're brand new. Come on, dude. Well, you said. Right, that's what we got from the second point. You guys.
Camera's a little.
If I've lost you somewhere. Otherwise, I'm just going to keep going like a crazy person.
Camera's a little low.
Oh, okay. Like it. So how do I solve for R? Somebody else than Jason. I know Jason's paying attention. How do I solve for R? What's a good first step? Don't over.
Exponential 1 over 20.
Say again, sorry?
Would you multiply by an exponential 1 over 20?
No.
Would you divide
Yes. By?
the 110,000 off of both sides?
Of course. So what do you always do when you're trying to solve an equation? You see where your variable is. It's in that little packet. You get rid of the rest of the shit that's with it. That's what you always do. Because to undo this, it's going to require something more than I heard somebody suggest, right? So what is that going to be, Jeff? I don't know. 29 over 22. Is that right? Does that sound right? Yes. Whatever the shit that is. It reduces to 29 over 22, I think. How do I kill that so I can solve for my R?
Would you divide?
No?
Would you use the log?
Yeah, which is kind of weird to me now that I think about it. Why is this in this section? But, oh well, too bad. So your natural log of this equals 20R, and then you can solve for R. Shaboom. Because that's what they want, right? They want you to figure out the annual growth rate, yeah. Nifty, but this is before you learn logarithms. Figure out.
So then it asks you to use that information to figure out what the cost would be in 2010.
Yeah, that'll be easy now. I mean, once you get what R and little a are, the last part of the question is easy. What I got to figure out is the way they wanted you to do this, because this is obviously way before we talked about logarithms. So they must intend for you to do this problem in a different way. No. Think about that one. So that one's going a little ahead. That one's using techniques that we've learned recently, but we wouldn't know in this section. I don't think they want you to know. All right, I got to think about that one. They must want you to do that a different way than what I'm thinking about. Because that's before we learned about logs. So obviously you can't use logs in that section yet. So that one's holding you back. Don't worry about that one. And unless I don't know if there's an example the way that they want you to do that problem. So the way I did it just now is the way that came to my mind first. Let me see. Well, all right, so yeah. So, I mean, once you get R and little a, everything is golden, because now you know. So whatever this comes out to be, why do I keep trying to use it? You're dead. So once we figure out little a and R, now we can plug in any time that we want to. Does that make sense? Once we know little a and R, then we can answer the last part of the question easy. It's just plug and chug. It's creating the function that's the hard part.
How would you figure out little a?
Little a we did, all right, so that was the first thing we did. So coming back, the first point that I see is we decided not to use 1985. We decided that T is going to represent the number of years since 1985. So then the first point we had then was 0, 110,000. Too many zeros. Is that cool? Right? That's 1985. It was worth $110,000. Right?
Yeah, that makes sense.
All right, I like it. So now I can just, oh, I forgot my little a. So now I can plug that information in. So A is $110,000. Why do I keep doing that? And T is going to be 0. So that's why A is 110,000 because E to the 0 is 1.
Okay, got it.
How would
That's what I got earlier, but I just wasn't sure because you were talking about finding A. So, thank you.
Yeah, little a, yeah. I
how
kind of
would
hate
you find the
little a.
little a if you're
Sorry?
not given the
What-
white intercepts? How would
What's
you
that?
find the little a if you were not given the white intercept?
That would be really hard. In fact, that's why you don't want to use 1985. We actually converted it to be the y-intercept. And the
Okay.
reason we can do that is because anytime I have growth rate, it doesn't care when the official t equals 0 is. Wherever things currently are, it's going to grow from there. So I can make t equals 0 anything I want to, as long as the rest of the time is built off of that. Does that make sense?
Yes.
Okay. So I can make t equals 0 correspond to the year 1985, because that's when things started for this problem. All right. Anyway, all right. I'm gonna have to think about that. I'm sure what they want from you there. So that's before we knew logs. There's another way to do it, but that's the first idea that came to my mind. But this is before we know logarithms. Is there another problem besides that one? So if that's the only problem that's giving you trouble in that section, that's okay. If you don't see another way to do it, just do that, turn it in, no worries. Somebody else asked me a question earlier. Here it is. Oh, there was a one from, all right, there's 2 questions from 6-2. I've got number 7. Oh, good. Okay, this is the one that came up the other day, and I can't remember who was telling me about this problem. Come to find out, and it wasn't the author, it was a colleague who's used this book before. She determined that that wasn't a typo. So if you do this problem, let me see what's happening. Oh, yeah, I got you. I think I got that. Somebody else has that same question, person who just chatted to me. So I'm going to do that next. Yeah, this should be a -2, come to find out. So she had sent me some notes she had been keeping when she was using this book, and she was going to send that into the author as suggested changes. So in the answer key, it actually uses x -2. So obviously they meant a 2 there, because otherwise you get some insane numbers. Is that right?
Yeah, it becomes like really weird. Like -5.5 e to the 11th.
Yeah, e means times 10 to the. So times 10 to the 11th power, meaning you move the decimal 11 times, make it that big. So
So if we
yeah,
have that answer, is it
You're
wrong? Do you want us to change it?
fine.
Okay.
You don't have to. But if you haven't done this problem yet, which is a little bad, it's back in 6-2. That's not a little bad, it's fine. Make that an x -2 and then do it. That's fine. If you already did it, then why would you be just, it's done. Who cares? But if
What
you haven't done
problem
it,
was it again?
number 7 and 6-2. So I had meant to say that yesterday, and I just, once the class started, I completely forgot to say that because somebody pointed out to me in office hours. Let me see. Another question I have is number 42, which is not a question, it's really an answer. But let's see. It's life, the universe, and everything. All right, so each graph is a transformation of 2 to the x. So if you look at 42, So that is different from 2 to the x in two major ways, maybe more. Can somebody see how that's different? What's one of the main ways that that's different from 2 to the x? This graph here. Arg. This one, there we go. Okay. Oh wait, you can't even see it. You can say that. It's all right.
Yeah, I was gonna say, I thought you were working on it, but yeah, we
No,
can't see it. Now we can see it.
all right. Everybody's just sitting there like, he thinks we can see that shit. All right. What happened now? You were just there. It doesn't matter. So this is, trust me, it's 42. What does 2 to the x look like? What's the basic shape? It's this dude, right? So one thing you can notice, there's two major things you can notice. The shape, how is it? I mean, the shape's the same, but just what's the major thing that's happened from this to this? There's two major things really, but what's one of the major things?
It
Anybody?
reflected.
Yes, there's a major reflection. It's just a mirror image reflection. So far, if I just consider that by itself, how would that change 2 to the x? Where would that change go in if I turned around?
It would make the exponent negative.
I like it. Let's see. I want to use, yeah, let's use this. So if I just turn this bad boy around, that would be, oops, let me call it g of x. 2 to the negative x, I like it. So is that, all right, so that obviously is a transformation that was used here to make it go from 2 to the x to this weird thing. Now, what else seems to have happened, at least?
Shifted
Where's
down.
the ask? Sorry, say again, sorry.
It's shifted down.
Yeah, in fact, how much? You could tell exactly how much.
4.
4. So I know it's been shifted down 4. But is that all? The thing you got to double check now is, was there possibly any shift left and right? So if I push it, is everybody, let me stop. I don't know why I'm doing all these problems for you. It's like I'm too excited and I want to know what the answer is. Because I haven't done these since I assigned them in the summer. But what you can do, is everybody with me? So I've got the reflection, I've got the shift down, but how do I tell if it's been shifted left or right at all?
You plug in a point and see if it matches up.
Oh, okay, that's acceptable. That's acceptable. So if I think that might be the answer, then I can plug in like 0 for x, and there better be a -2 that comes out, right? And is that currently what happens?
No.
No, it's been stretched.
Yeah, maybe it's been stretched. So one thing, so to double check that, all right, so you guys got a couple of ideas. Let me just throw one more at you. If I undo the shift down by 4 and see where it is, it might be easier to work with then. So maybe it has been stretched also. I like it. Is this enough to kind of finish this problem out with? You guys?
Yeah, it makes sense now.
One thing I did was, as I noticed definite things that have happened, I collected them in a function. Now I'm leaving space because I might have to put some shit next to this, or I might have to put something in front of this, or I might actually even have to put something in front of the x, right? If it's been stretched or compressed in this direction. But it seems like maybe it's been, something's happened here, which would go out front. Okay. So those kind of problems are a little harder to do, but I hope that something I said there gives you a plan of attack for these kind of problems. So the last thing I would have done is to undo the shift down by 4 so I can see what it looked like. And then that helps me tease out that last transformation by taking out one of the other transformations, making it go back closer to normal so that I can see what else happened to it. All right, that's all I'm going to say. We just find A and plug in points. Oh, you could, sure. Yeah, somebody else has a different idea. If you're pretty sure that it is, and I think that's what somebody else was pretty much hinting at. If you're pretty sure there's got to be a number that goes here, you can plug in a point and figure out what the number's going to be. You had to do that in a few different problems before anyway. So that'll work also. My way was more visual, which is kind of funny, but that's, I mean, I actually sometimes tend to do things a little less purely mathematically. But the pure mathematical way to do it is to say, okay, I think this is the last kind of shift that might have happened. Let me plug a point in and figure out what A has to be. Is that what you're suggesting there? Secret chatter? Yes, so that's a good idea. That'll work too. I like it. So what I want you guys to realize about this problem is everything I just told you, I figured it out as I was looking at the problem, right? I'm not, and that's a very scary way to teach, because sometimes I won't know exactly what to do to begin with, and I'm not just going to sit here and stare at it, so I've got to talk it out. So, but I like to show you some thought process, because I kind of hate it when teachers present problems fully done, and then you don't get to see, what did I think to do this problem? So as I do this kind of problem, I am thinking with you. I am thinking as I write. Maybe. So anything else? There's probably other ways to do this that haven't even come up yet. You're right. You're right. I agree with you. But it looks like it might be something nice. So let's see. What's kind of funny is I almost want to finish this problem. Ah, shit. What the hell? I gave you another problem that was like this earlier, right? Did I assign one before this?
Yes, there was another one.
So if we do this way, so if I plug a 0 in, I'm supposed to get -2, right? So -2 equals A times 2 to the -0 minus 4. So I got -2 equals A minus 4. So I get A is 2. Now what's the reason I wanted to finish this out? What's so flippin' cool about this? Is everybody decent what just happened? And I think somebody, the way you said your question earlier made me think that you actually saw that. If I move them all back up by 4, this actually goes up here, which is double where it's supposed to be, right? Okay, okay. Watch what else is cool about this. All right, all right. So I really want to make sure, let me know if you're really not at all with me. If you're
So
partially,
Is
that's
the
okay.
answer g as a function of x equals 4?
No, definitely not. So here's the answer. I just had to figure out what A is. So now that I know what A is,
Times the 2 to the power of -x.
now, can anybody simplify this for me? You can simplify this because these are the same base, right? Sorry, I'm writing like sideways, but it's just the way this setup makes me do. That's not going to help. Let's just keep going, dude. All right. Hey, look at that. Okay. Can anybody put those together? What do you do? What's the power on this 2? 1. That's right, kids. So then what happens when I put those together? What do I do with the powers? What's
Yeah.
happening?
Do you add them
Yeah.
together?
Yeah, let me write it a little bit weird. You could write 1 minus x, but let me write -x plus 1. So that's actually a what do you call it? A horizontal shift. But do you see how it's kind of nice that A, if there is a shift horizontally, it will have at least a component that will go together with the base that'll make that shift show up. I have no idea if you know what I just said. That's exactly what just happened. It became a part. It became the same as the base that made the shift show up. I like it. And to be really, really honest, just to blow your minds, that's really the way to look at this. So it'd be shift to the right 1, then reflect, and then down 4. All right. Could you have stopped right here? Sure. Is this even better? Yes. Is this even better? Yes. Okay. Anything else from homework stuff that I can like do for you for some reason? You might as well ask now when I'm in that mood. Maybe I'm out of that mood. Yeah, I think I'm out of that mood. It's too late. Too bad. Sorry. You can still ask a question, but it's not going to do it for you. No? Are we out? We out of questions? Oh shit. I should have asked before I did that. I'm sorry. I don't think I missed anything. No. Okay, so let's get back into where we were, and I will look into that problem from earlier. Now that I've got a way to do it in my head, I'm having trouble thinking about it in a different way. Okay, I'm all caught up on the chat. So what we did last time, we talked, let me really quickly, let's review what we did last time. So everybody's in the same place. I might have to readjust this, maybe. Okay. These you have to become pretty good with. So if I have log of something, the product of two things, A times M, why not? Let's change it up a little bit. So one property is the product rule. What happens when I have the log of a product? What happens?
It's equal to log B of A plus log B of M.
Yes. Yes. And a real quick, a concrete example of this. Wouldn't that be nice? Let me give you a concrete, because I think everything I did yesterday was very theoretical. So watch this. So if I had log base 2 of 4 times 8, and just go with it. I mean, you're all like, yeah, we're gonna go with you, dude. Get the shit. So I could do this way. Log base 2 of 32. How many 2's does it take to make 32?
5.
5. Okay, so I know whatever the hell I get over here better be 5. So since this is log of the base of a product of two things, I can break this up. What is log base 2 of 4?
2.
Yeah, because 2 squared is 4. What's log base 2 of 8?
3.
3, yeah, because 3 to the third power is 8. And sure enough, 5 is 2 plus 3. So what this property says is whatever's in here, if I wrote it in terms of that base, 2 squared, 2 cubed, what would I do with the powers? I would add them. That is what that says. That's all that line says. That focuses on the powers, and this focuses on the bases. Well, if the bases were the same, what would I do with their powers? I would add them. That's all it says. So how is that property actually used most often? I will show you. So everybody got that business? Okay. This is how the properties is used most often. Oh, sorry. You guys all right? Somebody just make a little, okay. What if I had log base 15 of 3 plus log base 15 of 5? Just to really, can I do either one of these directly by hand? Hell no. But what can I do? So the main way this property is used is actually backwards. It's for consolidating logarithms. So this would be, are they the same base? Yes. Is it adding 2 logs? Yes. So how can I rewrite this?
Log 15 to the 15.
Log 15, not 2 that, be careful. Be really careful. This is not a 2 that. That 15 is down, and this is a normal 15. Log base 15 of 15. So that's not a power. The answer is going to be the power this guy needs, which is why we write him down. So this symbol makes sense only because of that. This being here is kind of stupid, but oh well. They like their Latin, logarithmos. So what do you want to do? All right. And what is this? That's an easy one, right? What is that?
1.
Oh, exactly. So I couldn't do this. I couldn't do this. But when I add them, it becomes easy. All right, so that's the first property we talked about. I'm going to erase all this. And then we talked about the obvious analog to this would be this. What do I do then? Amazingly enough.
Subtract.
Yeah, it's great. So let me just say something right now. Can I do shit with this? Does that fall into any property we talked about?
Yeah, it would be log b of a, or not b of a, but log base b a divided by log, or am I thinking about this wrong?
You are.
No, it's log b of a over m, right?
No.
No?
No.
I'm being really stupid right now. Wait,
No.
so yeah, there's nothing we can do with this. Sorry, I'm
Don't
thinking of the
criticize
wrong thing.
yourself. That's what I'm here for.
Because it's all in parentheses, so there's nothing we can do with it, right?
Nothing to do with it. So one thing is, holy shit, never, don't start distribute. That doesn't make any sense. That's not log b times this, right? So you can't distribute this and then make it, no. So the property says nothing about the difference inside of a log. It's the log of the quotient is the difference in the logs, or the log of the product is the sum of the logs. It doesn't work the other way around at all. It doesn't know what the hell to do with this shit at all, right? It's the same idea. Remember, this is all about exponents, right? Can I do something, sit down there. Can I directly do something with this? Directly, without doing any weird shit. Can't I just square everything inside and be done with it, right? Can I directly do something with this without having to write other shit out? No, I can't distribute that. No, so that's that's very, very vaguely connected to why these work the one way they do, is because of what exponents can do and what they can't do. So it only works in this direction. Product inside is addition outside. Division inside is subtraction outside. I don't know if that makes sense. I don't know which way to say it, so that it'll stick in your brain. And then the last property, which I try to get you to understand is the most important in a way, but it's built off of this one. Forge out. Sure, why not? Oh, jeez. All right. Is this dude here BAP? Right? So this actually uses this property to eventually see what happens to this. If I have log of something and that something inside is 2 a power, what can I do with that power?
You move it to the front.
Yes, and make it
With-
log. And all that says is, if I have something raised to a power, raised to another power, what do I do with the powers? I multiply them. That's all that says. That is the most important one, because anything where the variable is stuck in the exponents, that is saying that any log can make that come down, so then I can actually solve the equation like we saw yesterday. Okay, I like it. All right. And just to apologize, every now and again, so real quick, when I started the class, I didn't have both my monitors like working. They were like not extending the screen. So when I started Zoom, it didn't know I had 2 monitors, and I normally have stuff on both screens, and I don't at the moment. It's freaking me out a little bit, but I'll be there. It was all because of the tea that anyway. So I want to show you more examples of, one more example of the simplifying a logarithmic expression. What the shit does that mean, Jeff? I'll show you. So let me see. If I have this, so everybody's got that. You should already have these in your notes somewhere, but these are obviously crazy important. So how can I simplify this, or can I? All right, so let me, if the problem had been this instead, could I do something?
It would just be log 4 C divided by A.
All right, now consider why that was easy. Exactly what makes that hard for some reason.
The number in front.
Coefficients, none of my properties have shit in front of the log. What the shit? So the first thing I've got to do is to get these damn things somewhere else. So obviously, always, whenever I ask this question, I want to know if somebody's thinking, I'll tell you where to put it, but where could I put this to get it the hell out the way? Where can it go back to?
As the exponent for C.
So obviously, the same thing can happen here. So just like anything, math goes both ways, right? Be jealous. Math goes both ways. So if it can bring a power down, it can put a power back up. And now it's exactly like we just did. Just these are a little more complicated, but who gives a shit? What would this be?
C to the 1/2 over A squared.
Does everybody see that? It's log base 4 of shit minus log base 4 of other shit. When I'm subtracting logs, it becomes a log of the quotient. And I want to, all right, let me show you a slightly easier problem. I want to make a big deal out of this because that's just who I am. All right. Once I got those coefficients out the way, I do have a property about the difference of logs. I do have that property. I don't have the property of the difference of half a log and twice a log. I don't have any property, but once I got those out of the way, bam. So there is something kind of cool. Maybe I can do it on this problem. So that's the answer, right? That's the answer. I'm going to try to sneak something in. You know, do your notes however you want to. But it's up to you. Can I write this like this? Yes? Right? Isn't that the same thing? And then can't I take the negative up? It's the same thing as taking like the whole -2 up. And then it would have been plus with a -2. It's the same idea. I want to, I'm just doing this. Oh, wait, I'm sorry. I missed what you said, so you're fine. And then what does this become? Log base 4 of, I'm adding 2 logs, so it'll be C to the 1/2 times A to the -2, but then where would this want to go? It's to a negative power, so it wants to go
In the denominator.
yes, and then it would match the answer we got earlier. So I'm not saying this is some other better way to do it. This is a stupider way to do it, but I want to show you why subtraction makes sense. It ends up on the bottom, because if you made an addition and used that property, it would still end up on the bottom. So minus going on the bottom is a shortcut, because it would be a negative power, it would go down anyway. So it actually isn't a second property. It's just the first property made into a second one as a shortcut. Maybe. Okay, I like it. So like I said earlier, homework, you're going to see problems that go this way, and you're going to see problems that ask you to break them back up and you want to go that way. You're going to see both ways, obviously, because if you can do it backwards and forwards, you understand it. Okay, so I want to remind you of something we did before. Did I miss something? No. Okay, good. We actually solved an exponential equation already. We solved 2 different kinds of exponential equations. We solved one like this. Write something. I don't know. Yeah. Sure. I like Let's see what happens to that. Is that going to be freaky, Jeff? Probably. I don't care. All right. That's not going to be bad. What's nice about this problem so that I don't have to bring logs in?
You could break 81 down.
To what?
To 9 squared.
Yes. So I can write both of them in terms of 9. And I really want to make a big deal out of what happens here. 81 is 9 squared, so I just did nothing. Go, Jeff. What do I do here?
Distribute the 2.
Yep. And now what's got to be true for this to be a true statement?
Three x minus 1 has to equal 2x plus 2.
Yes. 9 to this equals 9 to that. No, they got to be the same damn thing. All right, so that's got to equal that. And if I subtract that and add that, I get x is 3. Wow! It came out really nice. So a natural next question would be, okay, Jeff, what if I can't do that shit? Well, then that's too bad. It won't be this easy. Hopefully you agree with me that that's relatively easy. So you always pray for these numbers to work together. I could have broken them both down to 3, but that would have been silly. You always try to break it down the least amount that you can so that you keep these the smallest they can be. Just to, make it easy. All right, so I'm going to take this away. So what if I did have a problem like, let's start off nice. 11 to the x minus 1 equals, yeah, let's do this way. Yeah, Jeff, calm down, dude. Are those good numbers? I want somebody to say, yeah, they're fine. They just don't work the same way. All right. So, yeah, I kind of pushed you in the direction of saying these are bad, terrible numbers. Because they don't break down in terms of some base, some common base. But that last property of logarithms tells me I can use a log, because the whole problem with this, so again, just to really make this big point, if my variable is stuck on the bottom and I'm trying to solve, what would you do in this equation? Your next step?
Multiply by the denominator.
Multiply that up. Why did you do that? So you would make it not stuck in the bottom, right? If your equation was this, what would be your next step?
It's a cube, both sides.
Cube it, and it wouldn't be stuck in a cube root. So where's my variable stuck? It's stuck up here. I don't want it stuck up there. So I'm going to use the only function that can make it free from up there. And what do I normally use? Does somebody remember what mathematicians use?
Natural log.
Yeah, it's got one less letter. And why use that? Because it's on the face of my calculator. Right? It's the most easily accessible, either that or the common log, right? You can see that on the face of your calculator. So what can happen on this side now? You gotta be a little careful. What happens here? Why did I do that?
X minus
Yeah.
1 goes
So
in.
why is this the wrong way to write that? That's wrong. Why is that wrong? What's missing?
There should be parentheses.
Yes, thank you. Because that's a really easy mistake to make, and then suddenly you think the x is in effect. No. All right, now it's a little freaky, but what are these anyway? What are these? What are those? What are those? You're like, I don't know what you want from me. Oh, somebody asked. It literally is because there's one less letter to write. Person chatting to me. That's why it's LN and not LOG. There's a whole other letter. We don't have that kind of time. We got a lot of equations to solve. Let's math people. Shit. All right, that I admit that's a very vague question. These are numbers, aren't they? I would have accepted powers because that's what logs are, right? But they are just numbers, aren't they? I like it. What's a good next step to do here?
Get the logs on the same side.
Yeah, you're trying to solve for x, like always. So if you can, instead of distributing this, that would be disgusting. I could just divide by the damn thing. Jeff, what are you spelling? I don't know. And now I'm just one step away. Do you notice something very important? I have not made this into a decimal yet because I'm not freaking done yet. Don't start putting decimal shit here. No. In fact, I will tell you this, on a quiz, I will ask you for the exact answer and I will ask you for an approximate answer. So if I add 1, what kind of answer have I gotten? What is that?
Actual answer.
Yeah, that's the exact answer. And if you plug that shit in your calculator, I don't care what you write down here, it's going to be approximate. I don't care if you go out to the 18 billionth decimal place. You approximated a lot. All right. But at the same time, this is what I also call an unsatisfactory answer, right? If somebody said, I live 1 plus natural log of 7, though I had natural log 11 miles away, it's like, what the shit are you? So the more practical answer, what do you get when you plug that in the old calculator?
I got 1.811507563.
Come back to the first beginning. 1 point. Sorry.
8115.
Okay, I like blah, blah, blah. So I would tell you how much to round. So you wouldn't go and say, I don't want to see 16 decimal places. I also don't want you to round it to 2. That's obviously not good. Right? Okay. And that kind of makes sense because 11 to the first power would be 11. So this can't be 2. It's got to be less than 2. A little bit less than 2. It's a little bit less than 2. All right. It makes sense. All right, cool. I like it. I like it. 2 more problems, I think. And then, yeah, I want to let us out a little bit early. I want to have enough time to watch the debate. Because I just like to inflict the kind of torture to myself. I have no idea why.
And it's going to
just
be
wanna see if,
hilarious.
I know. I just want to see if some people are stalking other people on stage. I don't know. We'll see. We'll see what happens. I got my bingo card ready to go. So I want to do 2 more problems. So one is going to be a little bit harder example of what we just did. And then the next one is going to be kind of the next level up. So what do you got? Let's do, it doesn't matter. 5 to the 2x plus 1 equals 2 to the 3x minus 1. Sure. That looks nice and freakadelic. What's really going to suck about this problem is that they both have powers, right? So I'm just jumping into the worst example of one of these. So let's do this together. First step is obviously what? Because the bases are not going to work well together.
Take the natural log of both sides.
Natural log. And again, you could use log if you like that better for some reason. And I've already got this in your head, hopefully. When you bring that down, it has to be in parentheses. That is huge for this problem. Huge. So that comes down in parentheses. Now here's where things get nifty. And this is where you really have to, I have too many people doing shit like this. All right, now, don't write that shit. Why does that make no sense? I love this step.
But you left it too.
Yeah, it's sort of like me saying, can you solve this? And you say, sure, man, there you go. X equals 7 divided by the square root. All right, next problem. What the shit? So ln by itself don't mean shit. So that is not ln times 5. That is not ln times 2. All right. So this is worse than the last problem because if I divide both sides by one of the ln's, I still have to distribute that. So it's really up to you. Which one sounds better? What I normally do is I just go ahead and do this. But it's really up to you what you want to do. So I get 2x ln 5 plus ln 5 equals 3x ln 2 minus ln 2. You got to start looking at this as one little package, one little thing. It's a number. It's a gross number. So ln 2 is much better to write. No offense. We know what the next step is in solving an equation. What's the next step? Get my what's together on one side. Sorry.
Get the x's on the same side.
So get the x stuff on the same side. So let me subtract that. And let me subtract, and then get my constants on the same side. That sucks. Well, it's not that bad. 2x ln 5. It didn't matter what way you went. Equals, where am I at? Oh, why did I do that? Oh, this was just me making a point. I don't want to make it look like division. Now, you ready? You ready for this last? Normally, when I'm solving an equation, I can combine these. Can I combine these?
No.
Hell no, they're not like terms. But I can just go ahead and take an x out. And then how do I solve for x?
Divide.
Divide by the shit I don't want. Exactly. I had just the right amount of space. That's kind of funny. Jeff. Woo! So x equals that number. Whatever that number is. That's a yummy looking dude. So if you plug that in the calculator, you got to tell it what the top is, what the bottom is.
If we don't plug it into the calculator, you had mentioned that this is as specific as it's gonna get, right?
If this is the exact answer, and if they or me want an approximate answer, then you have to put all this in the calculator to get a decimal. And now it'll tell you round it to the 100th place or whatever. Is that cool?
Yeah.
Okay. All right, last example, and then we'll get out of here. What time is it? All right, good. I'm trying to figure out which way I want to go. There's a whole class of, do you want to do another one involving logarithms, or do you want to do one involving, what am I trying to say? Oh, no. All right, let me just make one up. I'll be the teacher. Let's see what happens. I'm going to erase all this shit. Is that all right? Okay. So as I was saying that, I was realizing we haven't done a problem like what I was thinking yet. So how would I do this? You do it, Jeff. There you go, buddy. Just to remind you, this doesn't count as another problem because this is just a reminder. If it was this, how could I solve this?
2 to the third equals x.
Yeah, so x is 8. Done. Yay! Why is that one worse than that?
Because it's got that little x minus 1 in there.
If it was that, though, wouldn't it be the same? So why is that worse? Because there are
There's
2
two of them?
logs.
Yeah, but what can we do about that? There aren't really 2 logs, because how can I rewrite this? It's log of base 2 of something minus log base 2 of something. So how can I rewrite that?
X over x minus 1.
Kick ass. So what happens here? 2 to the third power equals that, right? All right, let me stop for a minute. So see, that's another reason why knowing your properties of logs are important, because if I can consolidate them, and this is why we normally consolidate them, then I can attack that one. Just too many. Put them all together. Now kill them. Yay. Sorry. Very violent math that I teach. And then how do I solve that?
Multiply both sides by x minus 1.
Subtract x, add 8. I get x equals 8 sevenths eventually, right? Running out of room. Why is that okay? What can't go inside of a logarithm? What kind of number must I have to put it inside there? What kind of number goes inside? What's the only kind of number that works inside of a log?
0.
No, that's one of the ones that don't work. The domain of a logarithm. The inside must be
Greater than 0?
positive. I love it. So when I put 8 sevenths in, that's obviously fine. Is it okay in the other one? 8 sevenths minus 1, that's still positive. So you have to check the answer. Just like a rational equation or a radical equation, you got to check it to make sure it doesn't freak anybody out. All right, and that is officially enough for today. So some equations, you'll have a plus right there. So it would have been x times x minus 1, which would eventually lead to possibly factoring to solve, right? You would get a quadratic then. Okay. All right, so class is officially over. If you have a question, let me know if you want to ask before I leave.
Thank you. Enjoy your debate.
Oh, yes, I will. Be fantastic.
We have the quiz tomorrow, right? And it's going to be online, so we'll turn it in by Thursday.
I forgot. Those of you who are still here, maybe I should send an email. I don't know if you've noticed. Yeah, exactly. It'll work the same way as the last one, but I did put a video of solutions to the practice quiz that's up on Canvas. It's up there in the same place.
Okay, thank you.
Thank you.
Debate is trivial. I think you're right, but I still want to watch it.
I have a quick question about this last problem.
Yes.
Is there any world or way to say add the log base 2 x minus 1 to the other side and say that log 2x is equal to that and just solve like that?
All right. If you do that, then you eventually have to do to that side. So you have 2 to the 3 plus log 2. Do you see what I'm saying?
Yeah, it just gets gross and it's just.
Yeah.
Yeah.
But I mean, all right, as I say that, that would actually still work if you were very careful about understanding something. This is the way to make it very much in your face. I could have actually not even done this stuff.
Yeah.
And done something here to get there. And it would not have been obvious to somebody just learning this, for example, right? So I don't like to start there, but just to let you know, there is a way to do something. Even if you did add it over, it would still work the way that I'm thinking about, but it's not obvious.
Gotcha.
This is just easier to see and work with. Yeah.
Okay, makes sense. Thank you.
Well, all right, let's see. Dalton, you okay out there? I'm going to assume you are just great wherever you actually are. Okay.